Assalamu alaikum. Welcome to my channel. I'm Asif Math Corner. In our last lecture, we discussed about some non-empty set, either they are groups or not. First set was a set of natural number. We proved that set of natural number is not a group because identity element is not present and inverses of any set is not present. So the second set was set of whole numbers. Set of whole number was also not group because inverses were not present. The third set was set of integer. We proved that the set of integer is a group with respect to addition but not with respect to multiplication because multiplicative inverses are also not present in set of integers. So the next set was set of rational numbers p by q where p and q belongs to integers was grouped with respect to addition and with respect to multiplication as well. The fourth set was the set of real numbers. We proved that because the set of rational number is subset of real numbers, that's why if set of rational number is grouped with respect to multiplication and addition, then the set of real number is also grouped with respect to addition and multiplication because all the four properties fulfilled in these sets, associative law, closure law, identity and inverses are present. So the next set was the set of complex numbers. We proved that the set of complex number was also grouped with respect to addition and multiplication. And the last set was the set of matrices. We proved that set of set of matrices is also grouped with respect to addition, but with respect to multiplication is the only invertible matrices makes the group with respect to multiplication because non-invertible or singular matrices have not their inverses. That's why they do not make group with respect to multiplication. Today we will discuss very important example, a journal example. We introduce a journal operator, and by that operator we apply our four properties to check either it is a group or not. So let's start. The let steric be defined. Let steric be defined on q plus only positive integer rational numbers. Only on positive rational numbers. The a steric b is equal to ab by 2. Here is, I need your attention please. The steric operator is like that. When we operate a with b, it give us ab by 2. It means whenever the steric operator applied, 1 by 2 we will find. So like this, from this example, it also prove our closure property, but we prove it in the solution as well. Then he said that then a steric b steric c is equal to, we know that a steric b, as we discussed that a steric b is equal to ab by 2. Like that, a steric b means a multiplied b by 2, and steric c, the steric c, the second time this operator applied, that's why one more 1 by 2 will multiply with this. That's why the answer will be a multiplied by b multiplied c by 4. 1 by 2 will be of this steric and 1 by 2 will be of this steric. 2 times operator operate, that's why 1 by 2 is equal to 1 by 4. Likewise, a steric b steric c is equal to a steric bc by 2 and a steric b steric, here is 4, a b c by 4. Okay, this is our complete example. Now we are going to toward the solution. Let's have a look that let steric define on positive rational numbers. A steric b is equal to ab by 2. Here the first property we apply, the closure property. we know that A comma B belongs to rational numbers, positive rational numbers. We have A steric B as defined earlier in that example in the question, that A steric B is equal to AB by 2. Hence here the closure property holds, because when we take two elements and operate them by the given operator, it gives us the answer like that which we need. So here the closure law proved. The second is associative law. The associative property is also defined in the example as well. We take three elements A, B, C from positive rational numbers and operate them by the given operator A steric B steric C. We know that when the first time operate A steric B, 1 by 2 we gain, and when the second time we operate steric, one more 1 by 2 we gain, and 1 by 2 multiply 1 by 2, 1 by 4 means A B C by 4. This is our left hand side. Now come to the right hand side. A steric start bracket B steric C is equal to when we operate B steric C, then BC by 2 comes as the operator defined earlier, and when we second time operator define 1 by more 1 by 2 comes 1 by 2 multiply by 1 by 2, 1 by 4, and ABC by 4. Left hand side is equal to right hand side, hence the associative property hold. Our next property is identity. Here is, I need your attention please. The first two laws were very easy because in question already they were defined. For identity, the given condition is A steric B is equal to AB by 2. Let E belongs to positive rational numbers, and we know that the condition for the identity is any element multiplied by identity, or identity multiplied by any element give us that element. That's why A steric E is equal to E steric A is equal to A. So we need to think about that by applying the given condition. A steric E will be equal to AE by 2 by the given condition. This implies that we have to think that we should apply A steric E. The answer should be A. So what would be the identity? From here we think that A steric E, the answer should be A. So A steric E, the answer should be A. So what will be the E? It's mean that E will be 2. E will be 2 because as we operate E, A steric E give us 2 in denominator. That's why to balance denominator and numerator, 2 will cut with each other and it give us A. That's why we have to think that E should be 2. As we operate E A steric 2, A multiply by 2. So the operator give us in the denominator 2. So here is A. The answer is not 2 but A. A multiplied by 2 is equal to A. So A steric E give us A. It's mean that this implies when we put A on the right side and now we put A on the left side. 2 on the left side, 2 steric A means 2 multiplied by A by 2 because this is the given condition. So 2 will be cancelled with 2 and the answer is A. This implies that the E is equal to 2 is the identity element. Hence we find the identity element. It means the third condition is hold. Now only left was fourth condition, that is inverse. We are going to prove the inverse. For A belongs to positive rational numbers, A steric A inverse. A steric A inverse or A inverse steric A give us identity. This is the requirement of inverse. This is the requirement for the inverse. So by computing A steric A inverse, the given condition told us that A multiplied by A inverse, and in the denominator we find 2 as defined earlier. So here we think again, we have to think that oh, A will operate with inverse of A. What would be the inverse of A? What would be the inverse of A, so that when we operate A steric A inverse, that give us identity, and we know that identity E, we prove that identity E is equal to 2. We proved that earlier in identity that E is equal to 2. So we think that A inverse should be like that. When we operate it with A, it gives us 2. So the A inverse is equal to 4 by A. Why 4 by A? Let's compute. When we apply the operator A steric 4 by A, that by the given condition A multiplied by 4 give us 2 multiplied by A. The 2 is denominator by the definition. 2 A, here is the small a. The A cuts with A, cancel with A, and 2 cancel with 2. The table of 2 on the 4 will be 2 2s are 4. So answer is 2. It's mean to get the answer of 2, to get the identity element, we have to think that what would be the inverse of A. So inverse of A should be 4 by A, because when we apply A steric 4 by A, by given condition A multiplied by 4, and we take 2 in the denominator, A will be cancelled with A and 2 will cancel the 4 by table of 2. Hence A steric inverse A will be equal to 2. It's mean that A 4 by A, similarly 4 by A steric A inverse is equal to A 4 multiplied by A over A multiplied by 2 is equal to 2. Left hand side, right hand side has proved. This implies that the inverse A is equal to 4 by A. So we find the inverses as well. Hence the inverse of each element exists. That's why thus the positive rational number with the given operator steric is a group. Hence proved. I hope you will understand. In the next lecture we will inshallah discuss about the order of the group and the order of element, which is most important, order of element of the group. If you like this video, then please subscribe and share my video. Thank you so much.